Have you ever wondered what would happen if a star passed by our solar system? How would it affect the orbits of the planets and the climate of Earth? Well, a new study suggests that this might have actually happened 56 million years ago, and it could explain a mysterious period of rapid global warming that occurred at that time. So, if you are curious about how a star encounter could have altered Earth's orbit and climate, stay tuned and watch this video till the end. The method and results of the study. The study we are talking about was published on February 14, 2024, in the journal Astronomy and Astrophysics. The authors used computer simulations to explore the effects of passing stars on the orbital evolution of the solar system. Why did they do that? Well, they were interested in finding out if a passing star could have caused changes in Earth's orbit that coincided with a period of rapid global warming known as the Paleocene-Eocene thermal maximum, or PTM for short. The PTM was a time when Earth's temperature rose by up to 8 degrees in just a few million years, around 56 million years ago. This was a dramatic change that had profound impacts on the biosphere, such as the emergence of new species and the extinction of others. The researchers wanted to see if a passing star could have disturbed the orbits of the planets, changing their eccentricity and inclination. Eccentricity is a measure of how elliptical an orbit is, and inclination is a measure of how tilted an orbit is relative to the plane of the solar system. These orbital parameters affect the amount of solar energy that a planet receives and thus influence its climate. The researchers ran thousands of simulations, varying the initial conditions and the properties of the passing stars, such as their mass, velocity, and distance from the Sun. They found that in some cases, a star grazing the solar system could have indeed altered the orbits of the planets, especially the outer ones such as Jupiter, Saturn, Uranus, and Neptune. These changes could then propagate to the inner planets, such as Earth, through gravitational interactions. The researchers estimated that the probability of such a starry encounter happening in the last 100 million years was about 1 in 10,000. They also found that the orbital changes induced by a passing star could last for millions of years and could explain the observed variations in Earth's eccentricity and inclination at the time of the PTM. The implications and significance of the study. So, what does this study mean for our understanding of Earth's orbital history and its connection to climate change? Well, it means that we have to consider the possibility that Earth's orbit was not only influenced by the gravitational interactions of the planets within the solar system, but also by the external perturbations of passing stars. This adds a new layer of complexity and uncertainty to the orbital behavior of Earth and the other planets over long time scales. It also means that we have a new potential explanation for the PTM, one of the most extreme and enigmatic episodes of global warming in Earth's history. By changing Earth's orbit, a passing star could have affected the amount of solar energy that Earth received and thus influenced its climate. For example, a higher eccentricity could have increased the seasonal contrast between summer and winter, and a higher inclination could have changed the distribution of sunlight between the hemispheres. These changes could have triggered feedback in the carbon cycle, such as the release of methane from the ocean floor or the decomposition of organic matter on land, that could have amplified the warming effect. However, this is not the only possible cause of the PTM, and there are other factors that could have contributed to the ancient warming event, such as volcanic activity, asteroid impacts, or changes in ocean circulation. The study does not rule out these other scenarios, but rather offers a new perspective that could complement them. It also does not claim that the passing star was the sole or direct cause of the PTM, but rather that it could have been a contributing factor that set the stage for the warming event. The strengths and limitations of the study. Now that we have discussed the method, results, and implications of the study, let's evaluate its strengths and limitations. What are the pros and cons of this study, and what are the challenges and assumptions that it faces? One of the strengths of this study is its novelty and creativity. It is the first study to explore the effects of passing stars on the orbital evolution of the solar system and to link them to the PTM. It is also the first study to use realistic and rigorous simulations that account for the complex interactions of the solar system and the galaxy. So, it opens up new avenues of research and inquiry and challenges us to think outside the box when it comes to explaining Earth's orbital and climatic history. One of the limitations of this study is its lack of direct observational evidence. It relies on computer simulations, which are based on mathematical models and assumptions. the simulations are not able to reproduce the exact history of the solar system, but rather to explore the range of possible outcomes that could have occurred under different scenarios. They are also dependent on the initial conditions and the properties of the passing stars, which are uncertain and hard to constrain. Therefore, the study cannot prove or disprove that a passing star actually happened, or that it was responsible for the pattern. It can only show that it was possible and that it could have had an effect. Another limitation of this study is its difficulty in modeling the complex interactions of the solar system and the galaxy. It acknowledges that there are many factors that could affect the orbital evolution of the planets, such as the presence of other stars, planets, asteroids, comets, and dust in the galaxy, as well as the effects of general relativity and tidal forces. The study tries to account for some of these factors, but it admits that it cannot include all of them, and that some of them are poorly understood or unknown. Therefore, it cannot capture the full picture of the dynamics and chaos of the solar system and the galaxy, and it could miss some important details or mechanisms that could influence the outcome. What do you think about this? Leave it here in the comments and take the opportunity to like the video and subscribe to the channel for more videos like this.